So without further delays, it's a great pleasure for me to introduce our speaker today, who is going to speak about identifying opportunities and value in IoT place. Yeah. Okay, Mr. Aman leads strategy at Noob, a leading connected home company in Silicon Valley. He is excited about products that seamlessly blend into modern lifestyles. Over the last 10 years, he has worked with and invested in a variety of startups and has a broad background in strategy, operations, and deal making. He previously founded Applied Protein, a biotech company focused on supportive cancer treatments, which was acquired by Pivot Pharma. Okay, he earned a BTech in electrical engineering from IIT BHU and MBA from Carnegie Mellon's Tepper School of Business, where he was an inaugural Swartz Fellow. So, if I may please welcome Mr. Amanjyot Johar.
Thank you. Thank you for the introduction. Very pleased to be here. Thank you, everybody, for being so welcoming. As I was researching my trip, this is my first time in Kuala Lumpur, and my last name is Johar, and on the internet there was this weird statistic that said 29% of all Johars in the world live in Malaysia. So I'm already feeling very much at home. So thank you to Magic for having me here, and looking forward to interacting with almost everybody here. So quick things just that I observed, which are very encouraging, is there's a lot of first-timers in the room, so welcome. And I see a lot of women as well, and that's very encouraging in the field of technology, because as you see, a lot of products these days are being designed and used by everybody. Women should have a big role to play in the right from the design and conception stage. So I think that's a good thing. And I have 2 daughters myself, so always happy to see more women come forth. So a little bit about myself. I've had a pretty unusual story. I grew up in India, and I went to the IIT for my bachelor's in technology. I studied semiconductor engineering, and I never worked in semiconductor engineering. I went to the US and founded a software company the first time around. And we were doing okay until I went to business school to get a better understanding of what the business principles are behind running successful technology companies. And one more quick question. How many people here are students? Oh, good. Quite a few. So this is one of the things that I've also learned in my life is, as students, we are always placing a lot of more emphasis on technology, right? But at the same time, it's also, since the world is changing so rapidly, I think it is very important for everybody to take a step back from the technology and also think about what the use cases for the technology that they are developing are. So as a student, I highly encourage you to think about those aspects, and through the rest of the conversation here as well, I'll keep bringing that back in. So, just to give you a little bit of more flavor about how I got to where I am. Right after business school, I started a biopharmaceutical company, and I have no background in biopharmaceuticals, but it was just a good opportunity waiting to be exploited. The technology was good, but then we were really able to figure out the right business case for the drugs that we were developing. And very quickly we found that the idea of solving cancer also needs to come from solving the side effects related to chemotherapy and radiation. And that's where we focused on. The company got acquired after 4 years of working on it. And then I also realized that my strengths are more on technology rather than biosciences, so I came back into the world of technology. And since then I've worked and invested in about more than 25 to 30 opportunities, and almost 23, 24 of them have been acquired. now I spend a lot of time working with startups in terms of mentoring them, guiding them, and often play a role of an operating partner, because the technology is great, but if you can't really connect to the business side of it, or you can't take it to market, or you cannot solve really imperative business issues, then the company eventually dies, right? So those are the things that I focus a lot of my time on, in making sure that these technologies can grow and expand. So it is in that light I've been working in the space of IoT, and it is extremely exciting, because in the next 20 years, we are talking about connecting more than 1 trillion devices. That's 1 trillion devices that will be connected to the internet. So if you think about the Internet of Things, what it really means is anything that is connected to the internet or to a network, and you can access it over a network, you can access the information that it is creating over the network, and you can integrate it with any other device, or even your own lifestyle for that matter, to make a really compelling use case for it. So that's in a very short what the IoT or the Internet of Things means to me. And if you think about it, 1 trillion is not a big number. In the last 15 years, we've had almost 8 billion cell phones across the world today, right? And cell phone hasn't been around for a long period of time. It accelerated very quickly after the introduction of the iPhone and the smartphone, and almost 4 billion devices are now smartphones. So to get to that 1 trillion number in 20 years, think of it as every one of us, every one of you, just having connected to 100 devices. Now again, that sounds too much, but think about everything that you use in your life, and it could be connected to the internet. The light switches in your home, they can be connected to the internet. The watch you wear, the sneakers you wear, the cars you drive, right? Everything can be connected to the internet. And this is just a very commercial, consumer-centric view of it, but now you start taking that into industrial equipment. So everything that you are able to measure will be on the internet, and it will be connected to the internet. So 1 trillion seems like a big number, but it really is not. We will probably see much more connected devices in the future. And what that really does is it gives us a really big ability to measure things that we've so far not really thought about. The more these devices are connected, the more data we can get out of these devices. And again, this data can be coming from sensors. It can be coming from your Facebook or Twitter likes. It can be coming from the purchases you make online. And there's just a plethora of use cases where data can come in from. And what that starts doing is the more data you have, the better you can analyze it. The better you can analyze it, the better you can solve problems and make it relevant to your users. And the better you can solve problems, the better your products are. If your products are better, you automatically get more users. And it kind of creates this flywheel effect where you have to be bettering with every iteration, right? And this is what IoT also enables you to do. So, and moving from there, I'm still talking at a very high level here. What we'll start seeing, and we are already seeing this in the market, is that there is a rise in the connected intelligence of things, right? Now we have things like a Nest thermostat, which learns when you are home, when you are expected to come back home, what kind of temperatures do you like when it's raining, how cool your house should be when it's bright and sunny outside. And we are collecting all of this information. So some intelligence resides in the devices itself. Some intelligence resides in the sensors. There's a whole bunch of intelligence that now you're starting to see with edge devices such as the routers or Wi-Fi equipment that you have at your home. And moving from there, there's so much more intelligence when everything's connected to the cloud, because the cloud is now getting information from 1,000 other sources as well, right? So there's this buildup of intelligence, and collectively I term it as swarm intelligence, where you have clusters of or swarms of different data that all add up to create a much more meaningful intelligent system. And moving from here, sometime in the near future, and this is where the futurist Rakers will also talks about the singularity, where the collective intelligence of devices will exceed sometime in 2023 to 2045, the collective intelligence of devices or the artificial intelligence will exceed human intelligence. And that point of inflection is what they call as the singularity. It doesn't matter when it happens, but whenever it happens, it will have profound implications for how we devise our products, how we use them, and frankly, what are these products enabling us to do? So one of the companies that I work with is called Noob, and what we have is a light switch replacement. So it's very similar to the light switch that you have in your houses, right? It just turns on and turns off your lights at the very, very basic level, right? So, but what we've done on top of the light switch is we've given it some smart capabilities and built some intelligence into it, where we have an Android, kind of an Android stripped down version of a tablet on top of a light switch. And this thing then connects to all kinds of devices that you may have in your home. We can connect to Amazon's Alexa. I don't know how popular that is in Malaysia, not yet. Or Google Home, or any kind of smart device that can connect either over Wi-Fi or Zigbee or Z-Wave kind of protocols. We can connect it in there, right? So what that helps us do is now all of a sudden this light switch can be activated by voice. You can tell the light switch to turn and turn off your lights. It's just a new way of interacting with your light switch. And then this has got plenty of other sensors in there. We have motion sensors, we have temperature and humidity sensors, we have camera integrated. So all of these sensors can gather more information, and they can make the transition of home automation much more easier. And I'll talk about it as we go along. But the point here is that now you can monitor your energy usage. You can use this light switch as your entertainment hub, and almost everything that you can connect in the IoT realm can now connect to your light switch. And you don't really have to interact with it. It can be voice activated, or there's this app on your phone. You can control it through your phone. So it just gives a whole different dimension to interacting and with technology inside your home. Now the biggest problem with having a ton of these devices, though, is that as you increase the number of devices in your home, the complexity of integrating them increases severely, right? So the easiest way to think about it is that if you have 2 devices, you only have 1 connection. But with 3 devices, you have 3 connections, and with 4 devices, you now have 6 connections. So as you scale the number of devices, by the time you reach about 10 devices, you need to have almost 45 connections that need to be maintained and monitored continuously. Now that is the big challenge with having IoT sensors and devices around your home, because as a human, it's simply impossible for any one of us to wake up in the morning and monitor whether all of the 45 connections are active and alive or not. It's just not going to happen. And if my system keeps dropping a few connections that are important to me, I will go back and not use that system at all, because as a user, my needs are not being satisfied by the system, right? So now think about it this way. If there is such a problem connecting only 10 devices, how do you connect 8 billion devices that are projected to be on the internet by 2020? That's a Herculean task in itself. In the home automation space, home and consumer devices account for almost 3 billion devices throughout the world. In the industrial infrastructure, again, more than 3 billion. Transport and health are kind of slow movers, but once they start chugging along nicely, you can expect a hockey stick growth in the near future for them as well. But this is the complexity of solving the problem of IoT. You have to start baking in your thoughts and ideas right at the design stage. And if you are able to do that, then it's a pretty big market. As an entrepreneur, you can think about just the connected home market by 2020 is $400 billion. Now that's a huge market. If you can take even a 10% chunk of that, I would love to have a foothold in that market, right? And similarly for smart buildings, smart cities, really huge market opportunities. So there's potential to do a lot, but then all of it has to come in when you start thinking about your products. How many entrepreneurs in the room here? Anybody working in the IoT space trying to build devices? A few, quite a few. Oh, all right, good. That's always encouraging. So this is the kind of opportunities you can expect to when you start growing at scale. But to get to that point where you're managing so much of complexity, you have to have resort to artificial intelligence techniques, right? Today's techniques are somewhere fall in the area of either assisted intelligence, where the user plays a key role in determining what kind of intelligence they want out of the system. So on the light switch example that I gave you before, I still have to go out and connect my Nest thermostat to that light switch and tell it, configure it in a way where I'm getting the right energy usage data, right? We also have augmented intelligence today, where the technology enhances the user experience. So there are a variety of sensors growing from the light switch. Now if you have motion detectors and position sensors, I can program security right into the light switch for my home, right? But all of that needs to kind of move away from assisted and augmented intelligence to something called the autonomous intelligence, where the technology itself is invisible to the user. The user should not even know that this whole system is powered by technology so complicated that they can spend a whole lifetime and still not be able to understand it. So with that kind of autonomous intelligence, it is possible to reach that point, and the markets are large for that, because as we saw the previous numbers, they're all in the hundreds of billions of dollars, right? But you'll have to tackle complexity. And tackling huge complexity or exponential complexity actually starts very early on. Your products have to be designed in a way that they are able to tackle the complexity. What I mean by that is, here's a graph, right? There's a regular technology adoption cycle where somebody develops certain technology, right? And in the early phase, just because the technology is new, it starts gaining some traction. And then it peaks out, and based on what the value the technology is giving to the users, it can rapidly scale, right? And but the point here is to note is that there is some sort of a death trap in here, where entrepreneurs don't really realize that once they get excited only about the technology, they forget about the other side of the equation, which is the customer experience and the value that the customer is getting out of it. You can get too deep into technology, but if it is only incremental in terms of satisfying a customer's needs, they will not it's very unlikely that they will buy the technology. If they don't buy the technology, your company is failed, right? You have to get revenues, you have to get your users excited about the products. Otherwise, there's a big chance of falling into this death trap. And the way to avoid this is to very early on start thinking about the product and the market fit. What is the product that you're developing? Yes, the technology is great, but very quickly you have to figure out, why would somebody buy this product? What is the need that it satisfies in the market that is not being satisfied by any other product today? So once you start getting an idea of those markets, you can start figuring out how to overcome this death trap. And this is an extremely important part of an entrepreneurial journey. And this exactly happens to be the area where I focus a lot of my time and attention on, in making sure that the companies I've invested in or the companies that I'm working with do not fall into this trap. And there's solid data to back this up as well. If you think about the top reasons for consumer hardware failures, and IoT as a category would definitely fall into the hardware space, because you have to build the sensors and you have to build the devices before you can apply logic and software techniques to them. So the biggest reasons for failure: lack of consumer demand, 38%. Lack of interest after the initial crowd-funded successful campaign on Kickstarter or Indiegogo, 24%. Product strategy mistakes, manufacturing setbacks, right? All of these are significant and can be overcome if you start to think early on about what are the basic features that my users will like and would want to have in this product, right? And again, there's more data to say that so CB Insights looked at all sorts of consumer hardware funding from 2012, 2013 onwards. And of the 382 deals that they looked at, only three companies got a meaningful exit. And one of them was Oculus, and the other was Samsung's SmartThings Now. So the hardware journey is incredibly hard. You have to start thinking about your hardware design specifications, not from what technology can do, because technology can do everything today, but what is it that your users would want and love? And you have to start from there, and retrace your steps back to say, okay, this is a product that I can now build. And another way to kind of think about this is a template that I often follow when I'm thinking about product market fits and how to just understand the market, right? So there are literally 4 areas that as a CEO or as a senior executive in your company, you need to think about how to grow your company and make it a meaningful thing. You have to spend a lot of time thinking about the product, right? People, as I said, they do spend a lot of time about the product, but they don't think through the manufacturing issues that go in, right? And I think based out of Malaysia, you've got a really good manufacturing economy here as well. So I would encourage you to get that learning early on and avoid the false barriers to growth that people encounter just because they didn't think about the supply chain, or how do you build a product at scale. Building 20,000-30,000 pieces of some hardware is easy, but when you scale up to like 1 million, 10 million, that's where the complexity starts. And you have to start, if your designs are complex, that complexity will eventually be enough to kill your company. So you have to keep things simple. The other thing you have to be constantly worried about is, how do you engage your channels? How do you bring your product to market? This is something that entrepreneurs start to think very late in the cycle. Is this going to be a business to a consumer product, or is this going to be selling into businesses? There are different implications for each one of those. Now, if you think about the home automation space or selling something to a consumer like you and me, we are inundated every day with so much of marketing blitz that getting any amount of mind share for a consumer is hard unless you spend millions and millions of dollars in marketing, right? So is that the best way to take your product to the consumer, by doing a marketing blitz? Or can you tie up with certain other channels like distributors who go on and sell to, say, professional installers who come out to your home and install the product for you? And this is exactly what we found with the Noob product as well. We started off selling on Amazon, but very quickly we found that Amazon was not the right way to sell product, because people only go out and buy one or two of these, and they don't spend enough time to rewire their entire home. So we changed our strategy and went to the business consumer. All these electricians and professional installers who now are able to buy 10 of these light switch devices and install into their consumers' homes. And that's been a much more successful route for us than just selling it on Amazon, even though the product can literally be installed by anybody who can replace 4 screws in their home. But that's not the right way to sell the product. Another idea to go think about is, and this is what I've talked about a little bit previously as well, is your consumers. Why would they buy it? How would they buy it? And when would they buy it? There is seasonality associated with it. A lot of consumer demand, right? Closer to festivals, it peaks up. Closer to summers, when kids are out of school and everybody's out on a vacation, all kinds of demand drops down. So how do you account for that? These are things that can really kill your product, because if you launch a product in the lean season, nobody buys it, and then 3 months from that time, you're still struggling to explain to everybody why you didn't do great when you launched. On the other hand, you launch a product at a festive season and everybody buys it, and you have much better optics about the success of your product. So these are things that you need to constantly think about when designing the product itself. And lastly, you have to be worried about the brand that you're creating, because once your initial sales take off, then your brand can really create a big flywheel effect and ramp up your sales, right? So those are things that you need to think about very early on in the design cycle. So with that said, let's dig into some more use cases and reality, as I say, on what's really going on in the world of Internet of Things. So before the IoT revolution, I would say, if you think about the web model of doing business, right? It was a very static one-to-one interaction between a consumer and a product. So now it's even hard to even figure out. But if you go back, just look at your older phones, which were not smartphones. There was a phone and there was you, no other connectivity at all. All it was good for was a few text messages and a phone calls, right? That's what the use of the phone was. But in the IoT connected world, now your phone is useful for everything. You have your social networks in there. You can get your Fitbit data or your smartwatch or active health activity data in there. And you can create communities that keep changing over a period of time. So there's this dynamic interplay of a lot of interactions going on with just a single device, right? So one of the use cases, again, going back to that light switch company, is what we found in the smart homes and healthcare space. Now the way to kind of think about it is, what is the healthcare can mean all sorts of things to everybody, right? But what is the real pain point that our solution can solve? So what we've found out based on our interaction with consumers and customers is that a lot of people buy these devices for their elderly parents, because the parents are at home, they're not so savvy about technology, they cannot hook up their security systems or their medical things by themselves. So now here is a light switch that's very easy for them to use, and at the same time it's collecting a lot of useful information about how your parents are living in their home. Did they have a fall? We can figure that out, Are they in need for some medical emergency? We can provide a solution to that, all through different sorts of integrations. And playing on that, you kind of, the other thing we are doing with these light switches is we're taking them now into smart buildings and condominium towers, where you have hundreds of apartments in a building, and how do you make that building a net zero consumer of carbon, right? How do you reduce the carbon footprint for that building? Is by efficient monitoring of not only the energy, but also a lot of other things, like your water flow, right? We don't really consider water as something that can impact the carbon footprint, but there's a lot of evidence that yes, that needs to be taken into account. So we are working with a developer out in Toronto, Canada, and we are making their entire building of almost 200 condominium units carbon neutral, and that involves reworking their entire heating, cooling, and air conditioning systems, their water systems. The way they're just designing the entire building is now changed because of the mandate of being a net zero, having a net zero carbon footprint. And again, these are things that are exacerbated when it comes to autonomous vehicles, right? So with the IoT, your cars are no longer cars that take you from point A to point B, but all these cars are now interactive. These cars are talking to each other. As of today, there's lots of V2V, vehicle-to-vehicle communication. They are now starting to talk to infrastructure and other devices. So this is a roadmap from a tier 1 supplier for automotive components, and these are the things that you can expect coming out into your cars in the next 3 to 4 years. So you have capability to talk to any device, whether it's a bicyclist cycling on the road, your car will be able to sense that and apply autonomous braking to once it figures out, or steer itself away from the bicyclist or pedestrians, right? And then there's a whole bunch of other features coming in, probably when more electric cars come on the road. And you might have just heard about Norway and China almost saying no to gas-driven cars and going fully into electric cars. So for them, the cars have to integrate with your energy sources at home. They have to integrate to the grid. And I just recently realized how big of a problem it is to charge cars off the grid, because all of a sudden if you want your car to be charged in, say, the amount of time it takes to fill gas, you're dumping a whole bunch of energy into the batteries of the car, right? If in 5 minutes you want your car to be charged, that's not a simple task. You've got to rework your entire grid and the way energy is distributed and delivered to the transformers, and designing the end systems in a way that's acceptable for a car to be charged so quickly. So the vehicle has then got to be interacting with the infrastructure. So the opportunity is pretty large. We've talked about this. This is some numbers thrown out by various companies from Bosch to IDC and Cisco, irrespective of where those numbers are, right? We all know those are huge numbers. But the idea is that to make those things happen, your sensors and your technology costs for the individual components really have to go down to make it easier for the mass market to be able to adopt these products. And that is the kind of revolution that is happening now, because all of these big numbers are driven by one small number. And what we are seeing now is that all of your end devices have processors that have capability of integrating communication channels for under $1. Now that is huge, because communication if you are to enable IoT, communication is the biggest bottleneck. Now, how do you integrate a full communication stack onto a processor and still have it come under less than $1 is the biggest challenge. But I think we are now at the cusp of crossing that barrier, and as it becomes cheaper and cheaper, you'll see a lot more opportunities come up, not only on the hardware side of it, but also adding stacks of software on top of the processor itself. So, what I would like to focus now on is how do we start to think about all of these opportunities? And McKinsey had a really, really nice way of putting it. If you just read the underlined words, what it says is that to take advantage of these opportunities, the threats to incumbent players come from technologies that enable new businesses, which is outside of the way the company has defined its competitive space. So if you're a Google or if you're an Apple, you've already staked out your claim to say that this is where I want to compete on. Google says that we are a search company and nobody can be better than us on search. So as a small company, if you want to really fight that big battle with them, that's going to be a really, really uphill task. Not to say that it cannot be done. I'm sure in some period of time somebody will come out and upstage Google there, but that's not a battle that you want to pick without having the right resources on your team, right? So better to stay away from those explicitly, clearly defined competitive elements that companies talk about and focus on what your strengths are, right? And as an entrepreneur, you'll very frequently realize what your strengths are. You go out and talk to people and figure out why there is a problem that you're trying to solve, right? That's the first way to think about it, is what is a product that will really, really go out and solve a problem, no matter how small the problem is. But if you are able to solve a simple problem, you can always add more bells and whistles to it and solve other bigger problems. But you have to really put your brains together to figure out why a certain product is needed. What is the motivation for behind that? And from there, you can produce a product that actually solves that problem. The part how to do it is interesting because, as you might have seen, especially in the software-driven environments today, is how do you start to build out your product? And people will advise you that you have to go out and build a minimum viable product or an MVP. And people just go out and start building an MVP, not realizing why they are really building that MVP. So if you want to really build a car, start out by building a car. Don't start out by building a tire or a bicycle or a motorcycle. That's the wrong way to approach the problem, because you've already identified that you need a car. So no matter whether the car has an engine or it is being pushed by people, as long as you're building a car from day one, you're on the right track. But if you let go of that vision, you would have let go of your consumer need, and that would be a product failure right on day one. Also, you have to realize that one size does not fit all of your market needs, right? So your market needs are very specific, and your product has to be very specific as well. So as I was talking about senior living, one of the things that seniors really, really hate is having different sensors or devices on their body, right? And so there's a number of companies that started to say, okay, let's give them a watch instead because it's aesthetic, it looks good, it's useful, and it's functional. But guess what? People didn't even want to wear the watch, because for them, wearing the watch means you have to have a smartphone that the watch is tied to, and then they get confused about managing multiple devices. So here's a company called Kanega Watch. They came out with the watch only for seniors, and it doesn't require a cell phone connection. It's got a lot of features built right into the watch, and it's a really, really good product, right? Now, once the companies realize that, are there different areas that they can expand into? Sure. They can add more bells and whistles and make different versions of the same product, but at least they've got a real core product that a portion of their audience just loves, right? Similarly, these are guys out in Italy trying to track all the soil and air conditions to make better wine through growing better grapes. Can they expand from grapes to other produce? Sure, they can. But the biggest problem they're solving is for the wineries. And that's important. They've identified who their first customer is. And if they are successful with those first customers, it's a no-brainer for them to expand their market into so many different products. Similarly, there's this device. You can't tell a lot by looking at it, right? But what this device does, you just install it into your waste receptacles, and it just makes a note of when those waste baskets are full, and alerts somebody that these waste baskets need to be replaced. Now, this is a process that janitors used to do manually, and if you think about commercial buildings or warehouses, they would spend a good part of their day just walking between different trash receptacles, trying to figure out which ones are full and which one needs replacement. But here's a device that can do it for them. Now, can they expand from just trash receptacles into inventory management or warehouse management and things like that? Sure, they can. But here's a problem first that they are solving. So you have to realize when you're building the product, don't try to be everything to everybody. Focus on that one problem that will take you there. So solve for one and extend to many instead of solving for everybody. That's a surefire way to get lost in today's fast-moving market. And so how do you solve for one? You start building something, and at the same time you start talking to all of your prospective customers, see where you are getting the biggest traction from, and build that out first, right? And as you build that chain, you will learn a lot more about your customers and how they're using your product. So go down that path and keep working through that idea until something catches on, right? And when something catches on, it will surely lead to that hockey curve growth cycle, because you've pinpointed a really good problem to solve. So never let go of the idea that you are solving your customers' biggest problems, right? And then coming back to, again, Noob, the light switch company, we started with smart lighting. That was all we wanted to do. We just wanted to replace the light switch. But over a period of time, we started integrating with thermostats, smart appliances, HVAC systems, security. We can integrate with wearable devices. We can integrate with some of the features of autonomous cars, and we can integrate with plenty of smart energy meter technology. And so from a connected home play, we are now working in all of these different areas. But if we had started off to say that we'll devise a solution that will integrate all kinds of IoT devices, we would have failed. So from there, if we think about the value that the IoT chain creates, right? Where is it that companies can focus on to derive the biggest opportunities for themselves? So one way to think about it is you start at the sensor level. You have smart sensors. Smart sensors can include very, very basic things like temperature, pressure, humidity sensors, right? And then you embed them into smart objects like a light switch, right? And then that light switch has some connectivity elements that allow it to actually connect to the internet and become the IoT play there. That's where it starts with connectivity. and you get into platforms and custom softwares and applications that are built on top. The biggest value, of course, lies in a platform play, which takes up almost 30 to 40% of the value of the in the entire supply chain. But it's hard to start off as a platform because you have, first of all, it's a space that will always be dominated by a few big players. You already have Salesforce and Amazon and Microsoft and Google competing in that space. But at the same time, the number of players there will be very small. On the other hand, if you go down absolutely into the hardware side of things, it's a smaller value capture, but the volumes there are humongous. If I'm talking about 1 trillion connected devices, every device will have some sort of a connectivity stack. Every device will have some sort of a battery, and every device will have some sort of a hardware communications thing. So if you can figure out a way to play in that space, that in itself is extremely important. And the volume, what you lose in terms of the percentages, you make up in terms of volume, right? So there's different ways to attack the whole problem. So how do you think about the enablers for IoT, right? So if we are going to be building products in the IoT space, then most of these are coming from just my perspective of things and the companies that I've worked with, right? So there are essentially 5 things that I see that will enable rapid growth in the IoT side of things. From the hardware side, it's wireless communication and 5G, having better batteries, having better sensors and sensor clusters. And on the software side, where this field is extremely wide open right now, you have all sorts of data analytics and cloud services that will feed into each other, right? So when I say connectivity is a challenge, what it really means is that if you think about the internet, how the internet has evolved, the only way we had connectivity was through IPv4, right? And what that allowed for was only about 4.3 billion addresses, and when they were exhausted, it was hard to come up and scale connectivity. Now, in the world of IoT, everything is running off of IPv6. Now, even if you connect 1 trillion devices, we are never going to run out of IP addresses, right? So from a very simple connectivity addressing point standpoint, that's a problem that has been solved, right? Now, on top of that, we've moved away from only wired and Wi-Fi connectivity into Wi-Fi, Bluetooth, Zigbee, Z-Wave, right? and all sorts of different use cases will rely on different protocols, because you have to worry about your power issues, you have to worry about the distance over which you are communicating, the frequency over which you are communicating, and those will enable different ways of connecting. And that's what I mean. The enabler is a wide variety of protocols that are now available, right? And even on the connectivity side of things, you cannot have any connectivity without overwhelmingly redesigning the way you think about antennas and the hardware that goes behind it, right? So here's a couple of examples of the new age antennas that are being developed. These are in no way resemble any sorts of antennas that you've seen. They are tiny components that get embedded along with your laptops or your screens or your sensors, and they are really good for enhanced video capabilities. A laptop antenna that serves a MIMO architecture, or if you're moving into vehicle-to-vehicle communication, you're starting to see a lot more innovation on the hardware and antenna side of things. Similarly, if you noticed the recent launch of the Apple Watch, one of the things that they really proudly claimed was the antenna design, which is very clever. Anybody know what they designed? How they designed or where they designed, embedded the antenna? It's in the screen of the watch. The screen of the watch serves as the antenna. The 4G LTE antenna is right here on top of the screen. Now this thing would have been unimaginable a few years ago. And the only way these things are being enabled is because of better materials, better hardware resources available, and moving away from those 2G, 3G base station antennas into something that is very tiny form factor is essential. The other challenge to adoption of IoT has always been power, right? So for the last 30 years, the entire world has relied on lithium ion batteries. And well, these are really great. They work, and people have just been increasing the energy density incrementally for lithium ion. But as you might have noticed, they are unsafe because they have liquid electrolytes. They can explode anytime. Samsung had a big problem with that a couple of years ago, and that problem never seems to go away, right? And also, you cannot make those batteries tiny. If you're making a IoT device that has a very tiny footprint in the industrial world, you cannot put a AA or a AAA battery in there or any other lithium ion form factor. It's not going to happen because some of these devices need to be in the field for 10 years. How do you charge those batteries? How do you figure out when they need to be replaced, right? And if you've installed an IoT device, you just want it to work irrespective of what's happening. So another company that I'm involved with is actually we are making solid-state batteries. So with no liquid electrolytes, you can make these batteries into any size, any shape, and any power density that you want. We're still in the prototyping stages, but it looks pretty amazing. And those are the kind of innovations that will need to come out. And oh, forgot about this. So even when we are talking about the lithium ion, it is going to be a dominant technology for the next 10-15 years, simply because there's a huge installed capacity. There's only five major players in the world who work on lithium ion, and they have a huge installed base of for batteries. But those are geared towards applications not on the IoT side of things, but for autonomous cars, right? Electric cars. And Tesla and Panasonic, LG, they're doing a fantastic job of that. But then where they are out of the market is in the solid-state battery space. So solid-state batteries are definitely going to take off in the next 10 to 15 years, and they will take off they will enable a lot of different use cases for how you're building your IoT devices and hardware architectures. Another challenge that remains is in the just in sensing data, right? How do you enable these devices to sense data? So this is where people are now starting to build out not only simple standalone sensors, but having a cluster of sensors. So whether it's a smart home, whether it's a factory, whether it's in your car, there's going to be a space for multiple sensors, and all of those sensors will need to work together to create a cluster that is inherently more intelligent than than the capabilities of a single sensor. So what you also want is you deploy these sensors and then just forget about them. They keep working by themselves, and that's a hard problem to solve because let's say even if you embed a solid-state battery, how is that battery going to get charged, right? So you need some sort of an energy harvester on top of that device to make a real compelling case that this is a device that you can just put in. It will keep sensing for the end of its life, without you having to do anything. So some of these problems, of course, were solved by NASA when they sent all these spacecrafts into space, because there's no way to change things out there. But that's the exact kind of design thinking that's coming back into the IoT side of things as well. So so this is kind of alluding to the same thing, where you have sensor size is decreasing, the power of sensors is rapidly increasing, and there's a massive increase in the massive increase when it comes to computing on the edge. So in the last few years, a lot of companies created massive cloud structures, right? Simply because the processing wasn't available on the sensor side of things. Now with more powerful sensors, you can do a lot more processing locally and then only send some data to the cloud that is more meaningful and more impactful for a broader use case. And then these local sensors, they can integrate with, as I said, form different clusters of information. They can integrate, you can track novel behavior in the environment, something that you couldn't do previously. On the side of application enablement, this is where the software part kind of comes in. And the way people are starting to think about software applications are that you build these software applications only once, and then they're able to run on multiple protocols, multiple operating systems, multiple environments. So you're kind of isolating the application layer from whatever is underneath. And that's going to be a big factor in making sure that as you run more applications, your costs are controlled, and your versioning control you have versioning control for all of your software applications as well. And finally, I think the idea is that security is a must for IoT, right? You don't want IoT to disintegrate into Internet of Nothing, right? Because without adequate security, you will have nothing to integrate, right? So there's again a lot of different thoughts going on in this direction, whether you should have security embedded right at the sensor and into the hardware, or should you have layers of security? And those things, there's no clear winner right now, but as things progress, those will be very good opportunities for entrepreneurs to make a case of one way or the other. And then again, as I said, the complexity of connecting so many devices is huge, but you have to start and you have to design for one use case. Figure that out. As an entrepreneur, that's your job, that's your duty, that's where you make or break your company. Figure out that one use case and design for that. And then it's always easier to extend it to so many other cases that you will have a successful company. So as I say, design for everybody on the planet still starts from designing for one. What is that one problem that you're trying to solve? And you look at that, focus on that, expand and extend that into different other areas. So with that, I think I'll take questions and see what else we can have a conversation about. Well, that makes me nervous, because either nobody understood anything or they understood everything. So, yeah.
Hi, can you elaborate more on the security-wise, like cybersecurity concern on IoT devices?
Well, security is still evolving, right? There are so many different levels at which you can apply security. Whether security needs to be on the side of sensors? Should it be network security? Should your device, so sensors, if you go down that value chain, right, you have sensors and you have devices and you have your network. Where can you apply the most security? Ideal thing is that you should have security everywhere, right? But as you go down that path, you very quickly realize that to have security everywhere, you're obviously creating redundant mechanisms, which may be good for one application. So for example, I don't know if you hear about news coming out of America much or not here, but there's an Equifax credit rating agency that got hacked. Now, for them, it make a lot of sense to have security everywhere, right? If they are deploying some sort of an IoT device or any network configuration, security is paramount. But if you're in your home and obviously you don't want your home to be hacked, but can you just thwart the attack at your router level or at your gateway? And then it takes the pressure off of having every device with its own standardized security, and you're kind of behind a firewall, so to say, and somebody else is taking care of the security. So is that a better approach? I think from my experience working with Noob, I think that's obviously a better approach, because there's a lot of open source security that is being used at the edge or fog devices. And if there's a breach, it gets filled up pretty quickly. And so the exposure to the end devices is not that high. But if you start developing your own protocols for security and try to implement security everywhere, hackers are bound to hack it. So no matter how secure you think your systems are, somebody out there will come out and hack them. So again, depending on your application, you have to think about where in the chain you want your security and how to kind of go about it.
Thank you very much. Because like from where I was going is that you said that at one point we reached the singularity point where the human intelligence will, compared to the machine intelligence, human intelligence will be like far lesser, right? Mm-hmm. So at that point, like we have already reached the stage where Facebook shut down their AI system where two computers are actually communicating by themselves. Mm-hmm. So in terms of that, when we are designing a system, IoT system, how can we mitigate that, or how can we design to prevent this kind of mishaps? Or have you encountered any from your experience?
No, I haven't encountered anything so far yet. I'm sure mishaps will happen, and whenever they happen, we have to be quick about addressing those. So from my experience, I mean, just with Noob, as I said, it's an open source security that we are using right at the gateway itself. So that frees us from the botheration of having to secure every end device and every sensor that we have, because we assume that the security at the gateway will be enough to protect everything downstream.
Thank you.
Hello. Hello.
Hi.
I have a question.
Yes.
I'd like to ask about to you is beacon. You know beacon?
Yeah.
Can you explain to me more about how beacon is linked to IoT system?
So beacons are an interesting technology because as you find, they are being increasingly used in all sorts of public places, right? But one of the things with beacons, and which is pretty good from a security standpoint, is that beacons do not have any payload, right? So there is no real, it's a connectivity mechanism with no real information on it. So going back to his point, do you want information security at a beacon level is probably not essential, right? So, I mean, there will be other cases where you want your beacons to give you the exact geofencing information, and you don't want them to be impersonated by somebody else. That's a different level of security that we're talking about. Yes.
Hi.
Hi.
You're talking about the communication, which is the biggest hurdle between the sensor and the network. Why wireless, not connected communication? What's your point?
Well, there are obviously two schools of thought. So Cisco as a company has bet, and this is my understanding, everything on wired communication. So they do a lot of, all of their IoT deployments still go through a lot of wired communication links. But there are obviously use cases where it is almost impossible to put in wires, right? And there will be those use cases where you're sitting on top of a cell phone base station, right? Maybe measuring just wind speeds, and because these antennas are going to be in the next 5G iteration pretty tiny and line of sight, and you don't want misalignment in that, right? But there may not be always a way to run a wire up there, especially because in the 5G realm, you've got ample bandwidth, right? So why waste? Economically, it will not be feasible to run a wire everywhere when you can achieve the same result wirelessly, right? So again, it depends on the use case where you want wiring and where you don't want wiring. In industrial complexes that Cisco does a lot of work in, there are already existing Ethernet cables over which they can route, or power line cables over which they can route Ethernet, right? So it makes a lot more sense for them to go down that path and cut costs. Ultimately, economics and the cost play a big role in whatever that decision is.
Good afternoon.
Good afternoon.
I'm Farouk from Wadwani Isal UTM KL. I came across this company that use, they call it Wi-tricity, using wireless electricity, sometime back in America. How does it actually relate to the development of the solid-state battery? Does it have any impact on the future of charging these batteries? Thank you.
So I don't know if I'm familiar with this particular company.
Yeah, it's using resonance magnetism to charge batteries without wires.
So I think that technology has been around for a while. Right now you have charging pads. You go to Starbucks and you can charge your cell phones by putting them on a charging pad. So it's probably going to be the same thing, even with respect to solid-state batteries.
Okay, will the solid-state batteries replace all sorts of batteries like lithium ion?
Well, as an investor in one of those solid-state batteries, I hope so. That's what I'm betting on.
Okay.
But it's out in the future right now, right? Because there is, at least for the next 7 to 8 years, there is no conceivable option that can topple the lithium-ion batteries that we are using today. Right, so unless that you reach that tipping point, it's hard to say. But one of the things that this is interesting, because as it relates to the IoT world, what I think is going to happen is, when I showed you that $1 number, right, and that includes today that includes the processing and the communication costs. I think in the next 5 to 10 years, that will also include the battery cost and the energy harvester on top of that, whether it's a solar or piezoelectric or whatever it is. Those sensors and those devices need to come down to that price point for such a huge mass market adoption. So I think there will be a new technology will make that happen. I'm already starting to see things work in that direction. So hopefully we'll see solid state replace every other battery.
Thank you, Joe.
Yes.
I have a question on one of your chart that says the revenue opportunities.
Yes.
What do you mean by cities? Because cities technically envelopes buildings, homes, and so on. So it's another word. Is it government services?
Yes, it's more related to infrastructural services to enable smart and autonomous vehicles to function properly. Foundation. So you'll have sensors embedded in the roads. You'll have red lights tailored according to the image processing that these cars are using, right? Walkways for pedestrians. So there will be a lot more infrastructure requirements that will need to be, that'll need the government to step in to make these things happen. So I think that revenue number includes those sorts of opportunities.
That would be investment that it flows. But
Yes.
this is chicken and egg situation.
Mhm.
Back to the subscriber, it's always the $1, the intrinsic value is always the whole. It's either the building or the transport where there's transactional value. So infrastructure will be there. Either telco providers pay a certain fee for certain trenching or certain.
Exactly. So it'll be some sort of a public-private funding for such infrastructure. That's, I think that's almost akin to saying how do you really develop out the whole telecom infrastructure, right? Because now the government is in the business of licensing these bandwidths. So would the government be licensing rights to highway usages? And so that industry can come in and bid for those profitable routes, lay the infrastructure so that everybody else can come in and build on top of that. So all of these are models that will play out, and I think there's a lot of value in how, in just going back into history and looking at how the telecom licenses were laid out. I think it's going to be similar to that. Not 100% similar, but there will be commonalities and elements that will be common between them and the new age infrastructure development.
The second question relates back to the first is IoT value chain.
Mm-hmm.
You mentioned earlier the platform is the most difficult to deploy, but it relies back on platform. I would assume is the government, the standards,
Mm-hmm.
policy. Let's say all spectrums in telcos are unlicensed. It's going to be haywire. There's going to be a spaghetti in the
You may
cloud.
want to take the
Oh, sorry. Back to the second question relates back to the first. When you mention about IoT platform, does it mean policies, government platforms that facilitate different industries so that they don't mess things up among each other? So if the traffic has no order, you will always have congestion.
No, I think on that slide, what I meant by platforms were private companies. So think about AWS as a platform for IoT, Amazon Web Services, or Salesforce, or the Microsoft Azure systems, or any one of those private players who can ingest a lot of data and give you an output related to that data, right? And on that platform, you'll have techniques like machine learning, and those are things that I think will be platform plays, because for smaller individual companies to get access to all sorts of data, train it in the right way, will be a big challenge. Whereas companies like Google, Facebook, they are already resting on so much of data that training for them is just a very easy job, so to say, right? So I think those guys will still play a really big role in extracting the value out of IoT. But then where new companies can come in is really finding that edge, and players can move from the sensors and the devices all the way to applications, right? And they can provide their own platform as well. So similar to how Noob is, we started off as a device company, right? But now, as we are getting more and more sales, we are starting to build out our own data platform, right? And so that we are not reliant on Amazon or a Google to give us the profile for the user. We know that our device is deployed in the user's home, and this is the use case, and this is how we can develop out our own platform. We don't need assistance from others right now. So it was more on the private side of things, and companies can move horizontally across that entire value chain, because if you're along with the device, if you're creating an app, right? So you're kind of in two different verticals along that chain. Now, the next step from the app is, can you build your own platform? For some companies, it may be an easy job. For a lot of others, it may not be.
Thank you.
Any last question? No? Okay.
Okay. All right, thank you.
That's it.
Thank you, everybody.
Okay, thank you, Mr. Aman, for a very enlightening session today. Very informative, and we hope that we would, all of us would benefit from this. So before we end, again, I would like to highlight on the, just to remind to fill up the survey, download the app, the Bizabo app, get the survey out and fill it up, get the chance to win the prize. Any one of you who just came in just now, I actually spell it out, the prizes that that you can actually possibly win, including the PS4 and some the vouchers, Starbucks vouchers, Zalora and whatnot. So yeah, grab the chance, and you can have your lunch outside at the CWS downstairs, first floor, right? First floor. Okay, and we are going, the next session will be at 4:30. We have Miss Alitza Sen. The topic is 10 practical ways to get started with Google Analytics by her. Yeah, so hope to see you soon for the next session. Thank you very much. 4:30, yes.